Let us talk about this problem. We are given a binary matrix. Our task is to find out largest rectangular submatrix in it. We mainly need to find out size of such a submatrix. So if we consider this binary matrix, these submatrices with all ones are, this is one submatrix of size 1 cross 2. This is one submatrix of size 2 cross 4. This is also a submatrix of size 3 cross 2. Which one is the largest among all? So the largest one is this one with 8 ones in it. So our output is 8. Let's now see this example. Here we have this submatrix, we have this submatrix, and then we have this submatrix of largest size. This has 6 ones in it. So our output is 6. Let's see this example. In this example, we have all zeros. So our output is 0. There is no 1 at all. In this example, we have only 1. So our output is 1. In this example, we have all ones, so our output is 3, all ones present in the matrix itself. Now please pause this video and try to think of an approach that takes a binary matrix as input and returns an integer value which is size of the largest submatrix with all ones. Let us first talk about a naive solution to solve the problem, and you can in fact call it super naive solution, because this solution, what we are suggesting, that we consider every cell as a starting point of a rectangle, right? And if it is 0, you simply ignore it. If it is 1, then you consider all sized rectangles where this is the leftmost cell. You consider a rectangle of size 1 cross 1, then 1 cross 2, then 1 cross 3, then 2 cross 1, 2 cross 2, 2 cross 3, then 3 cross 1, 3 cross 2, 3 cross 3. So you basically generate all pairs of numbers where one pair is according to the number of rows and the other pair value is according to the number of columns. So to traverse through every cell and consider every cell as a starting point, you need big O of RC loop, right? You need big O of RC loop, right? And then once you have picked a cell by doing a big O of RC loop, inside this loop, once you have picked a cell, then you are going to again run a big O of RC loop to generate all size pairs, right? You again need a big O of RC loop inside this loop to generate all pairs, right? And then for every pair, you check if it has all ones or not. Suppose you generated a pair of size 1 cross 1, then you check if this matrix has all ones or not. If it has 1, then you update the result if current value or the size of the current rectangle is more than the result. Then you generate a pair 1 cross 2 and then you check if it has all ones or not. Then you generate a pair 1 cross 3, then 2 cross 1, then 2 cross 2, and for every pair value you check if it has all ones or not, right? So, and checking for all ones is again going to be a big O of R into C time. These are upper bounds, right? Because you are actually going to run less than the row and columns, and even for the sizes. But if you want to find an upper bound, then it's going to be big O of RC loop. Inside this, you have another big O of RC loop, and inside this, you have another big O of RC loop, right? So this is going to be big O of R cube into C cube solution. There exists a much better solution. We are going to talk about a solution which is big O of R into C only, right? Please pause this video and try to think of optimizing this super naive solution. In fact, the solution that we are going to discuss is very interesting. It's based on the largest area histogram problem that we have discussed in the previous videos. Let us first do a quick recap of the largest area in a histogram problem. So in that problem, we were given an array, right? Like this, we have array 10, 5, 6, 2, where every value inside this array represents height of a bar in a histogram. So this array actually represents this histogram, 10, then 5, then 6, and then 2. We need to find out the largest rectangular area inside this histogram. And if you look at this histogram, you can notice that the largest area is this one. And the area is 5 into 3. We consider width of every bar as 1, right? And we simply take the heights and multiply it by number of bars, right? So height of these bars is the minimum height among these bars is 5, and 5 into 3 is 15, right? That's our output. And suppose this bar is of length 20, in that case our output will become 20. This single bar will give you the largest area 20, right? So that was our largest area, largest rectangular area in a histogram problem was. Now please pause this video and try to think
how can we use this solution as a subroutine to find out largest rectangular matrix with all ones in a given matrix. Let's now talk about the idea of the efficient solution. So what we do in this efficient solution, we traverse the matrix row by row. First we traverse this row, then this row, then this row, then this row. And when we are at this row, what we do, we consider this as a histogram problem, right, with bars of height 0, 1, 1, 0. And we compute the area for this and we get the area as 2. We update the result as 2. Now when we come to the next row, what are we going to do? We are going to consider this as the base and we are going to consider this as a histogram. Right, so histogram with height 1, with height 2, with height 2 and with height 1. And suppose if there was a 0, then we would consider this as a height 0 even if there is a 1 above it, because the base is 0. Right, so this is 0. So we now consider this histogram array with 1, 2, 2, 1. And for this array, we get the largest area in this histogram as 2 into 2, 4. Right, 1 into 4 is also 4, right? But we get the area as 4. So we update our result as 4. Now we come to the next row, and whenever you are moving down the row, what are you doing? If you see a 1, then you add 1 to the previous value. Suppose you had a 1 here, you added 0 plus 1, 1, 1 plus 1, 2, 1 plus 1, 2, 0 plus 1, 1. Now you again do the same thing for this row, 1 plus 1, 2, 2 plus 1, 3, 2 plus 1, 3 and 1 plus 1, 2. Now you consider this as a base of the histogram and you compute the area of the largest histogram, and this time you are going to get 2 into 4, 8 as the largest area. So you are going to again update the result. And this is interesting, the last row, because you have some zeros here, right? This is an example. So what we do here, we see a 1 here, so we update 2 plus 1, 3, we see a 1 here, we make 3 plus 1, 4, but when we see a 0, we keep it as 0, right? We make it as 0, right? So we make it as 0, we make it as 0. Right, because the base of this is 0. So this is a histogram of height 4, this is a histogram of height 3. Now we get the area this time as 3 into 2, 6. And we already have the result as 8, so we don't update the result, our result remains 6. So I have given you enough idea about the solution. I have in fact given the example also with the explanation. Now please pause this video and try to write down the complete solution yourself. You can use largest histogram area function, right? You can copy that function from that problem that you must have written already and use this function as a subroutine and write this function.
Let us now talk about the implementation. I have written a pseudocode here. This code is close to both C++ and Java. So I've written a function, max rectangle. This function takes a matrix as input, and what this function does, for the first row, it finds the largest histogram area by passing the first row as it is. So if my input matrix is this, it's going to pass 1, 0, 0, 1, 1 to this largest histogram function, and it's going to get the result as 2. Because if you see this array, and if you try to draw the histogram, you are going to get 1, then you have 0, then you have 0 again, then you have 2 1s. So this is the largest rectangular area, so you get the output as 2 for the first call. Now we are beginning from the second row. We begin with I equal to 1. And what we do for every row that we do, we consider this row as a base and we try to find out heights of bars. And how do we find out heights of bars? See, if current cell is 0, then this height is going to be 0 for sure, because this is the base and these 3 are 0, so we don't consider this one. We simply have these 3 heights as 0. But when you have value 1, we can simply add the above value and that way we can find out the height of bar. So this height becomes 2, this height becomes 2. So we now pass this modified row to our largest histogram function. And largest histogram function is going to consider these 2 bars of height 2 and then 2 of 0. And it's going to give you the result as 4. That's what we have done here. The first thing that we have done here is we have built the base for histogram, right? We have computed these heights to 2, right? And we are traversing through the whole row, right? And we are simply checking if it is 1, then we are adding the above cell value. If it is 0, we are ignoring it, right? It's going to be 0. And after doing this, we are calling the largest histogram function here and comparing the result with the above result, and if the current result is more, then we are going to update the result if the current value returned by this largest histogram function is more. And this max is C++ style. If you're programming in Java, you can use math.max. So we call this function for every row as a base, right? So we call this for this row, and after this row is processed, we go to the next row. I becomes 2, and we come here, and now we again do the same thing. If all the values are 1 here, so we are always going to go inside this if condition, and we are going to add the above values. So this is going to remain 1 because our value is 0. So these 3 remain 1, and these 2 become 3, 3. So this is our new input for largest histogram function. We call the largest histogram function here with this input. We get the output as 6. See, the largest histogram area that we are going to get is 3 into 2, which is 6. So we get the 6 value and we compare it with the current result. Current result is 4. So we are going to get a higher value here. So we update the result. We get the result as 6. Now we go to the next row, and we are going to again consider it as a base. So we are going to increment the values. This is going to become 0. These two are going to become 2, 2, right? So we have these two as 1. So we are going to add the above value. These two become 4, 4. Now we provide this as input to our largest histogram function, and we get the largest area as 8, right? 4 into 4, 8. 4 plus 4, 8. You could also get 2 into 4, 8, right? Both are giving 8, so you can consider any of those two. And your result is updated to 8, and at the end you simply return the result. Now how is the time complexity? Theta of r into c. We are running r and c loops, and inside these loops we are doing constant work. And then in theta r loop we are calling largest histogram function, which is a linear time function. So our array size is c, so it's going to take big O of c time. So we are doing we are doing theta c work, then we are doing big O of c work inside a loop which is theta r. So our overall work is theta of r into c. Let's now talk about auxiliary space required for this solution. See, I have considered an integer binary matrix here. If I am given a Boolean matrix, then I can't modify it. For ease of implementation, I have considered only integer matrix. And there might be cases like even if you have given integer matrix, you're not allowed to modify the input. You need to get the area, not to modify the input. In those cases, we can create a new row of size c, and that will require theta of c auxiliary space. And this much big O of c auxiliary space is anyways required by the largest histogram function. This requires a stack to give you the largest area of the histogram. So we can say overall space required by the solution is theta of c, and theta of c is required by this, and big O of c is required by this, and theta c you would need for storing the individual rows so that you can create rows and you can pass the largest histogram function. You can create an array and pass this to largest histogram function. So this is an efficient solution, works in theta of r into c time, and requires big O of c or theta of c auxiliary space.